There is a moment most people recognize. The bill arrives, the number is higher than expected, and there is nothing to do except pay it. No way to negotiate the rate, no way to change where the power comes from, no way to have any real say in a system that runs quietly in the background until it doesn't. That feeling of being a passenger in something you depend on completely is what pushes some people to start looking for a different relationship with energy. HAT search is what this is about. The infrastructure behind everyday electricity usually stays out of sight. Power plants, transmission lines, substations, transformers, and distribution networks operate in the background, while electricity arrives at a wall outlet with little effort required from the homeowner. The system is designed around centralized generation and distribution. Large facilities produce electricity, transmission networks move it across long distances, and local infrastructure delivers it to individual homes. For more than a century, this structure has formed the foundation of residential power access in much of the world. One of the less discussed characteristics of this arrangement is that the homeowner typically has limited involvement in how electricity is produced. Energy consumption can be reduced through efficiency improvements, different appliances, or changes in daily habits, but the generation side of the equation usually remains outside the homeowner's control. A person can decide to turn off unused lights, but they generally do not influence where their electricity originates or how it reaches their home. That separation between consumption and production has led some people to explore alternatives. The motivation varies. For some, it is preparedness during outages. For others, it is an interest in self-reliance or learning how energy systems work. In rural areas, backup power may be considered a practical concern. In urban environments, rising utility costs sometimes encourage people to investigate different approaches to residential energy use. Several options already exist within this space. Solar systems allow homeowners to generate electricity on-site, although installation costs, roof conditions, permitting requirements, and local regulations can influence the process. Portable generators provide temporary power during outages but typically require fuel, storage space, and ongoing maintenance. Battery systems occupy another category, storing electricity for later use while introducing their own cost and capacity considerations. Each approach addresses a different aspect of energy independence. Some prioritize long-term generation. Others focus on backup power during emergencies. Some require professional installation, while others are designed for consumer assembly. The landscape includes a wide range of solutions, each with different requirements, costs, and levels of involvement from the user. Within this landscape, the energy revolution system occupies a different position. Rather than being a physical generator, battery, or solar panel, the energy revolution system is a digital information product. It is a collection of blueprints on schematics, instructions, and educational materials centered around a small-scale electricity generation project built around concepts associated with Nikola Tesla's bifilar pancake coil design. The product is delivered digitally after purchase. Buyers receive access to downloadable materials that include diagrams, component lists, assembly instructions, and supporting documentation. No physical hardware is shipped. The product itself consists entirely of information intended to guide the construction process. The emphasis is placed on learning how to assemble a device using separately acquired components rather than purchasing a completed piece of equipment. The presentation of the system is closely tied to historical references involving Nikola Tesla and one of his patents from the late 19th century. The materials spend significant time discussing Tesla's work, his inventions, and the concept of a bifilar pancake coil. These historical elements provide the framework through which the project is introduced and explained. From a practical standpoint, the user's experience begins with obtaining the digital materials and reviewing the instructions. The blueprints outline the components required for assembly and describe how those components are intended to fit together. The process involves sourcing parts independently, typically through electronic suppliers, hardware stores, or other component vendors depending on availability. A person following the instructions would spend time identifying the required materials, organizing the components, and preparing a workspace suitable for small-scale assembly. The exact setup depends on the builder's environment, but generally involves a table or workbench, basic hand tools, and sufficient space to handle wiring, connectors, and other electrical components described in the plans. The assembly process itself is intended to be sequential. Users move through the diagrams, connect specified parts, construct coil assemblies, and configure the device according to the provided instructions. The materials are structured to guide the user through each stage rather than requiring them to design a system independently. In that sense, the product functions more like a project guide than an engineering textbook. The level of technical experience required will vary depending on the individual. Someone already familiar with electronics, DIY projects, or electrical components may recognize many of the parts and procedures immediately. Others may spend more time becoming familiar with terminology, identifying components, and understanding how the various sections of the project fit together. Once assembly is complete, the project transitions from construction into operation. At that stage, the focus shifts from building to monitoring, maintaining, and understanding the device as described in the documentation. The product positions the project as something that can remain in place after setup rather than requiring constant daily interaction. Like many DIY systems, however, the experience does not necessarily end once construction is finished. Components may require inspection. Connections may need periodic checking. Users may revisit the documentation to adjust configurations, review instructions, or better understand the principles behind the design. The system is therefore positioned less as a one-time purchase and more as an ongoing hobby or personal project. The practical limitations are largely structural rather than technical. The product is not a turnkey appliance, and it is not delivered as a finished consumer device. The user is responsible for obtaining materials, completing assembly, and following any applicable local regulations. The documentation itself notes that implementation requirements may vary depending on location, and that users should consult local authorities when appropriate. The people most naturally aligned with a product like the Energy Revolution system tend to be individuals who already enjoy hands-on projects, DIY builders, preparedness enthusiasts, hobbyists interested in electronics, and people who spend time exploring alternative energy concepts are likely to recognize the format immediately. For these users, the process of learning, assembling, and experimenting may be as important as the finished project itself. Others may find the format less aligned with their expectations. Someone looking for a ready-to-use backup power solution, a professionally installed energy system, or a plug-and-play consumer appliance would encounter a very different experience here. The Energy Revolution system is fundamentally a set of instructions and educational materials rather than a manufactured energy product. Compared with solar panels, the distinction is straightforward. Solar systems focus on installed hardware that generates electricity from sunlight. The Energy Revolution system focuses on providing information for a self-built project. Compared with conventional generators, the difference is also structural. A generator is a finished machine purchased from a manufacturer, while this product centers on plans and assembly instructions. Compared with battery systems, the contrast shifts again. Batteries primarily store energy generated elsewhere. The Energy Revolution system is a project focused on energy generation concepts rather than energy storage. Each occupies a different position within the broader category of residential energy technologies. Viewed as a whole, the Energy Revolution system is best understood as a digital blueprint package built around a DIY energy project inspired by Tesla's bipolar pancake coil. The buyer receives plans, diagrams, instructions, and educational materials rather than physical equipment. The experience involves sourcing components, following assembly procedures, and engaging directly with the construction process itself. The larger question is not simply how a person powers a home, but how much involvement they want in understanding and participating in the systems that provide that power in the first place. For anyone who wants to explore it further, the guide is linked in the description below.